Hey guys, so today we're going to talk about pages 630 to 633. So before we just jump right on into this, make sure you have all of your highlighters and a pencil. Make sure, I'm going to repeat myself, do not tear out these pages. I repeat, do not tear out the pages from your book. Keep them in, that way you have them all in one spot. Okie dokie, let's get right on into it. So, I'm on page 630, so I'm going to read the top, and then I'm going to go to the active reading and go from there. Okie dokie. So, from the time of Democritus, scientists have studied matter and proposed theories about it. What do we now think about what makes up matter? Great question. Okie dokie. With pencil, underline, active reading. As you read the next page, draw a line from each part of the atom diagram to the sentences that describe it. Okay. Suppose you could break a silver chain into smaller and smaller pieces. The pieces would become so small that you couldn't see them without a microscope. How small could the pieces get before they were no longer silver? The answer, 1 silver atom. An atom? An atom is the smallest unit of an element that maintains the properties of that element. The atomic theory. Well, the atomic theory is a scientific explanation of the structure of atoms and how they interact with other atoms. Democritus first suggested that the smallest part of matter is 1 atom. Over the years, the theories that scientists made about atoms have changed as scientists learn more about atoms. Now, in orange highlighter, you need to highlight the definition of an atom and atomic theory. In green highlighter, you need to highlight the sentence about Democritus, first suggesting the smallest part of matter is an atom. Okay. Now, let's take a step back and let's look down at the bottom of the page. Gold is one type of matter. Now, we see a gold brick. We see flakes of gold. Are they both gold? Yes. Are they different sizes and different shapes? Yes. But they're still matter. Does that make sense? Now, up top, really quick, I'm going to zoom up, that way you can see it. Up at the top. More than 2,000 years ago, I stated that all matter is made of tiny solid balls called atoms. The word atom means indivisible. So in blue highlighter, I need you to highlight. The word atom means indivisible. Okay, now think of a piece of paper. Now, in my hand right now, I have a Post-it note. It's a piece of paper. I'm going to tear it in half. Okay, I'm going to tear it one more. Okay, well, now I can start tearing it in half. Once, twice, and one last time. Okay, I've ripped up this piece of paper so many times that I still have a piece of paper, but they're different sizes. An atom is like a piece of paper ripped to its smallest part, but it's still paper. Does that make sense? Take the closest piece of paper that you have that does not have any writing on it, and that is important, people. Let's take like a Post-it note or a loose leaf piece of paper and rip it up as small as you can. And you have it in your hand. Is that little thing on your finger or in the palm of your hand, is that still paper? Yeah, it is. Think of an atom like that. Okay? Now, think of gold. You have the gold brick, and then you break it down to flakes of gold. Well, when you get all the way down to the flakes of gold, we have these things called gold atoms. So, at the bottom of page 631, you're going to highlight in pink. Draw an arrow pointing to a single gold atom. You can probably already see my little line. But it's right here, and it's just pointing to 1. Okay? Now, that's an atom. Just like that little piece of paper thing that we just did. You break it down as much as you possible, but the very last piece cannot be divided. Does that make sense? Okay. I'm going to erase my line, but you can still see it. Okie dokie. So let's go back to the top of this page. Atoms are the building blocks of all matter. You can highlight that in orange. Okay. Now in the top example box, I'm going to read it and then I'm going to ask you to highlight it. Current atomic theory states that an atom is mostly empty space. Well, at its center, there is a small, dense core called the nucleus. Refer back to the beginning of this year. You have already learned about nucleus, so this should not be a new concept to you. Back into the present day. The nucleus is surrounded by electrons. Whoa, hold up, backtrack. Let's think about that really quick. That first sentence in that box you need to highlight in blue. The word nucleus needs to be in orange, and the very last sentence needs to be in pink. Now, whoa, nucleus? We've already covered about nucleus. What are you trying to say? Well, what I'm trying to say is an actual atom, okay? The atom itself is made up of different items. Now, you can already see there are 3 different types that we will be going over today, okay? Bear with me. We have protons, neutrons, and electrons. Now, with your pencil, you will need to write 1 next to proton, 2 next to neutron, and 3 next to electron. Okie dokie. Now that you have that written down, let's go over this really quick, okay? In our active reading, it said to draw a line from each part of the atom diagram to the sentence that describes it. So we're going to go one by one. We're going to start with number 1, then go to number 2, then number 3. Okie dokie. Proton. What? A proton. Pro. P-R-O. Pro. It's a positively charged particle found in the nucleus of an atom. These protons have a positive charge. Now, when we think positive, we just went over this with our temperatures. Let's think. Proton, positive. Positive means plus sign. So our protons are these red lines, okay? It's from this little thing up here. That little ball, that red ball with the white plus sign in it, that's a proton because it is positively charged. Neutron. 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 Neutral. A neutron is neutral. So these neutrons are particles also found in the nucleus, but neutrons have no charge. They're neutral. So next to no charge, take your pencil and write N-E-U-T-R-A-L. These are neutral. And under proton, you're going to circle the word positively because they're positive. Protons positive, neutrons neutral. Okay, now where are the neutrons, you might ask? Well, do you see where the proton is, that little red ball with the white plus sign in it? The neutrons are next to the protons. So, your neutrons are these little white circles, these white balls in the middle. Okay, so those are the neutrons. Electrons. 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 Okay, now here is how I remember electrons. If you look at the capital E in electron, you see the middle line of E? It kind of looks like a minus sign. The way I always am able to think of electron is that minus sign in the middle of the E is negative. So electrons are negative. So electrons are negatively charged particles that speed through an area around the nucleus called electron cloud. Da, da, da. Electron cloud? What's a cloud? Well, all of this empty space around the center of the proton and neutrons. So that's our nucleus, where our proton and neutron is. All of this space around the nucleus, and you can kind of see where this circle ends. You see all the way around here? That's this area right here, where I'm putting all the dots, this is the cloud, okay? Our electrons are these little balls right here moving all over the place. So I'm going to take my pencil and I'm going to draw a line from this one right here to the word electron. Does that make sense? Awesome. Okie dokie. So under electron, you will need to circle the word negatively charged. Awesome. But you also want to underline with your pencil, speed through an area around the nucleus called electron cloud. Awesome. Okay, let's move on. Now, at the bottom of the page, it says in green highlighter, use the Venn diagram to compare and contrast electrons and protons. Okay, now, let's get this straight. You will be doing 2 items. You will be writing 2 items for electron and 2 items for proton. You will write one thing that both things have, okay? So, next to one, under my word, proton and electron. Okay, proton. Proton is pro, so that's positive, okay? It's our positively charged. And our electrons is our minus, so that's our negatively charged. Okay, now from here, if I know protons are positive and electrons are negative, next to the number 1 inside of your Venn diagram, you're going to write proton under proton, positively charged and negatively charged. Negatively charged. Okie dokie. Now freeze. Number 2, you are going to do on your own for proton and electron. And you have to write one thing that both things are. Now, both things are located where? What's that word that we looked at earlier? Yeah. Nucleus. Hint, hint.